Hi everyone, this is the second instruction on the expert curve modeling Addon. As you have already realized, the instructions are aimed at explaining how to use the functions, while the tutorials are aimed at practical application. Today we will look at how to work with the new conversion function, mesh to ECM. I recommend to watch the video to the end. If you plan to use this function, there are some peculiarities in its use. As you have already seen in this accelerated video, this function allows us to convert a mesh object into vertices, curves, segments of our expert curve modeling Addon. Note the topology. I'll start my explanation with a simple, let's call cube mesh, and just make it complicated. I think many people have been waiting for this feature as it allows you to use all the Blender features and then convert everything. Note the grid here consists of quads. Triangles are also allowed. I will tell you about how you can use GONs a little later. Be sure to click on the mesh analysis at the beginning to make sure that everything is in order. If you have inscriptions below, it means that the object needs to be corrected later on. We don't have any problems. We can convert this to ECM. You will see below that the conversion is in progress. At this point, it is better not to do any other actions. Our conversion is complete, but I seem to have forgotten to turn off the wireframe display. All the necessary collections have been created, and you can now work as usual. I'm not going to dwell on what you already know. I'm just highlighting handles and changing the shape of the selected curves. Let's spin the grid a little bit. I'll leave it up to your imagination. Also, almost forgot, your mesh object that you convert doesn't disappear, it's just hidden. Let's look at the problems that arise. Let's take a look at what triangles, quad, and GONs look like in Blender. Triangle has 3 vertices, quad has 4 vertices, GON has more than 4 vertices. Now let's see how it works in the ECM Addon. Let's add a triangle, and it's kind of made up of quads. And here we're no longer considering the mesh vertices. Here we're only looking at the Vertex ECM. Let's create a plane, and it too consists of quads. The difference between GON and quad. Quad has 4 vertices, and GON has many vertices. We have about the same thing. In Vertex mode, you can see 4 ECM vertices, but they are not mesh vertices. There are a lot of mesh vertices here. Our ECM vertices are built on the joints of curves. This is the mechanics of our ECM segments and control using the curves of the meshes that are created. If there were no mesh, it would be a GON, because each curve is converted to mesh by a set of vertices and edges, but they have no branches, so each vertex has only 1 or 2 edges connected in a chain. Now let's see how this works for conversion. See, our ECM vertices will be built on vertices with 3 or more edges. We do a background check, and we have no problem with it. Let's subdivide these edges. For Blender, it's gons, but for ECM, it's still quads. We added Vertex, but they look like a chain, and these Vertex only have 2 edges, so Vertex ECM will not be built on them. Vertex ECM will only be built at the intersection of 3 edges or more. I pressed Analyze Mesh, and there's no problem either. Let's say we want to do Extrude. Now the situation has changed, as they will now be considered gon ECM. Now these vertices have 3 edges each. And we have 5 ECM vertex. And if you just hit the Convert button, you don't have any segments at that location. We do the analysis, and he found 5 ECM gons. We click on the highlight button, and it selects them for us. There are several options to remedy these situations. You need to either complete the topology or use the fix function. Different actions will help you in different cases. In the fix function, you have 2 algorithms to build the mesh, either via triangles then quads, or via poke face then quads. On cylindrical shapes, through poke face works better, but in some cases you will be better off using tris to quad. It is also possible to complete the loops, or you can simply remove these gons and close already in ECM modes. It all depends on how you will be more convenient. Now when we update the analysis, the problems will go away. And it converts everything, but let's go back and look at another method that's less obvious. If you have a chain of vertices, they become one curve. That is, if you take and dissolve the edges here and leave the vertices, it will work as well. Do the same with the others, and we won't have any more problems. It's kind of hard to explain. I think you just need to see it. This is how we get one curve at this location. So this vertex, which was just a point in a chain of consecutive edges, just became a point in this curve. That's how they all became ECM quads. I'm not sure I've been able to explain. I think with practice, or when you try it yourself, you'll understand more. Just focus on mesh analysis, and it will become more clear to you at what points you need to do something about it. This method is more for advanced users. We'll play with the curve points a little bit to give you a break, and then we'll move on. Let's try to convert a cylinder. I think a lot of people will need it. Don't make a lot of extra mesh. I don't think you'll need a lot of it. As with anything else, if you have an even resolution on the cylinder, you also have a better built grid on the lid. Here we have 2 gon ECM detected. In this case, the fix will work best. Check again for errors. There are no more. Now you can do whatever you want with it. Now let's take a look at Phase 2 vertex error detection. We made something out of the plane. As you can see, we will have ECM points right here. And here we have two edges, and logically the Vertex ECM will not be built here, but we need it. But I can make you happy. I have prescribed such a case separately. And if you have a face with 4 vertices or 3 vertices, it will automatically detect them as Vertex ECM. So why do we have a line for such an error? The thing is, if you have a GON here on the edge of the meshes that also has only 2 vertex ECMs, if it's a GON with 3 or 4 vertex ECMs, then no problem. But if it only has 2 vertex ECMs, then that's a problem. This part will become a solid curve when converted, which is not good. When analyzing, you will immediately show a similar face, so there is no sense to look for it. It is corrected quite simply. You need to specify which vertices you will have ECM vertices. But remember, you only need to select 1 or 2 vertices to get either a triangle or a quad. You don't need to select all the vertices of the face or do any weird stuff. When you click on the Fix button, you will have micro extrudes from these vertices, so that these vertices have 3 edges. If you need to roll back, just select this point with a frame and make merge, or take a step back. Of course, if you want to do by distance, it is better to do it before adjustments or mesh analysis, so that you do not die your adjustments. But this error is very rare. So many people may not even meet it. Now that's a separate curve for you. Let me take a step back and pick the other 2 vertices so you can see what it affects again. The main thing is that when you press Select, don't press the Fix button right away. You only have to choose 2 vertex. I think that the bevel will be used often, so I want to say that it is better to make it on one segment, so you will be easier to work with it in the future. To make a large segmentation bevel, I think there is no special sense. Don't make the bevel too shallow. Triangular segments may not like it. The geonode of triangular segments has merged since they are made up of squares. During the tests, I noticed it reminded me of something, but I can't figure out what it is. So we are done with this feature. Hopefully I was detailed enough. In practice videos, or maybe in time lapses or shorts, I will touch on this feature some more. A little snippet at the request of a subscriber about the difference between select point and select handle selections. Let's start with select handle. The internal curve manipulators are selected. This allows you to change the curve bend and the shape of the segment. But there is no change in the scale of the segment movement. The Vertex ECM control points remain in place. Therefore, this is only used to change the shape or bend. Let's also curve the shape here. And the other function, which is called select point, it allows us to select all handles and control points of curves which are on the intersection of Vertex ECM. It is more convenient to use it in Vertex mode or segment mode. Be sure to highlight the active object, one of them. This selection allows you to move, scale, and possibly even rotate without breaking the curves, thus keeping the segments intact. I think it would be a good idea to update the origin right away. You can use it in other modes as well, for example, if you want to move this part or multiple parts. This is actually the difference. Selecting handle allows you to change the shape of a segment by bending it. Selecting point allows you to move and change the scale of the object segments. Thanks to everyone who made it to the end, from you like, subscribe, comment. I put all the effort I had a couple weeks to develop this feature. Hope you appreciate. See you in the next video.